So we are going to carry on. We're going to solve equations by drawing the graphs, but we're going to do it by hand this time rather than using the computer. When it asks you to solve a system of equations and gives you two equations, what are we looking for?
The point where they intersect.
Point where they intersect, yeah. So where the two lines cross, that's the visuals of it. All right, so we've got two lines. I'm hoping you will know how to graph these two pretty simply, but we're going to go through it anyway. What form of the equation is that?
Y equals x plus b.
What's it called though? Gradient intercept. Why is it called gradient intercept? Because it's the gradient in the intercept. For this first one, what's the gradient, what's the intercept? Almost. The gradient's 2. And the intercept is? So when we say the gradient is 2 and the intercept is -6, what does that actually mean?
The y-intercept is negative.
So the y-axis intercept is -6. And when we say a gradient of 2, what do we mean?
It goes up 2 for every one.
For each 1 on the x, it goes up by 2 in the y. Good. Right. So I have, and this is why I said don't draw this, because you're going to do it yourself in a sec when you figured out what size. What I've done is I've got a set of axes here, and oh, I didn't mean to do that. Oh, rubbish.
You can command Z.
No, I had all my fast forward. Oh, I've lost it. Oh, rubbish. Right. I have 2 dots. All right. One at 3. Okay. The other one is at -6. Why have I done that? That's the start of both of the lines. So I'm just going to do the 2x minus 6. So I've got my starting point. I'm just going with squares because actually counting squares in this one is nice and easy. All I'm really interested in is finding out where the two lines cross. That's it. So it's got to be done accurately and properly, but we're not too worried about scales as long as where they cross fits on my page. All right. Now I've got a bit of experience in knowing that it starts at -6 and goes up, and this one starts at +3 and goes up, but not quite as steeply. So I know they're going to cross in this sort of area. All right, that's where I'm using my critical thinking skills to set my axes up before I just draw a cross in the middle of the page and then start drawing it. Oh, I need another sheet of paper and I've got to start again because it doesn't cross. Right, so I've used that information. So I'm going to just go through. It starts at -6 and I've got to go across 1 up 2. So I'm just going to do that a few times. That across 1 up 2, put a point, across 1 up 2. Are you all happy with what I'm doing here?
Yeah.
Yeah, so I've done some points. Now, how many points do you actually need?
An infinite number. As many as fill the page.
How many points do I need to draw my line? 2. All right. Why did I do lots? Just to show you what's up. I mean, I could have just done a couple, all right, and then drawn my line through it. The more you've got, the more accurately, but once I know where my line's going, I can draw my line, okay? Now, what people do, though, is they draw their line, or they put some points, and then they just draw their line and do that. Just lazy, all right? And the trouble with that is, all right, if you've got lots of points, it's very obvious that that's a bad line. But if I've only got 2, it might not be quite so clear. Does that make sense? So that's why I've done quite a few points, just so because this is an accurate drawing, I'm going to make sure that I've done the right thing. All right, let's have a look at the next line then. So we're starting at +3. Right, so this time the equation is x plus 3. So I'm starting at +3 and I'm going across 1 up 1. Cross 1 up So I can then spot actually that I'm just going to draw, okay, a few points. And you can see that the cross actually is on my page. All right. Now, why is that useful? Well, that's useful now because I can now go down. Now, because it's an accurate drawing done properly, not just a rough sketch, I can now count my squares, right? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's at let's change my things, right? So that's at 12. And this one's at 1, 2, 3, 4, 5, 6, 7, 8, 9. So what are the solutions?
9, 12.
Almost. What are my solutions?
Solution.
9, 0, 0, 4.
My solutions are at x equals 9, y equals 12.
Yeah.
All right.
Same thing.
We could write 9, 12 as a coordinate, but I want x equals 9. That is all right because I know that it's x and y in coordinates. Just saying 9 and 12 or 12 and 9 doesn't tell me which number is supposed to go with which. Okay, so there you go. There's the solution to the first one. All right. I'm going to let you try that in a sec, but just before you do, the next one we're going to have a look at is this one. All right. Why is this one different?
Did you have to convert the...
Potentially, yeah, it's not in gradient intercept form. So one of the options is to convert it. But what I'm going to get you to do first is make sure that you can replicate what I've just done there in your notebook. Okay. Right. So another example is I've gone all the way to E, and the reason why I did this one as the next example is, as you've already said, neither of them are in the gradient intercept form that's so easy to graph. All right. So you've got a choice, I guess. One is to deal with it as it is and still graph it. The other way is to convert to gradient intercept form because we know how to graph that. So what should we do?
Convert.
You think convert?
Yeah.
Okay, well, let's have a look at the first one then. So y minus 7 equals 6x. What can we do to convert that one into gradient intercept form?
Just add 7.
Add 7, isn't it? So that one's a definite. Let's just make it into 6x plus 7. So we can use that. This one, we've got 3y plus 12x subtract 6 equals 0. Add 6. So that would be 3y's plus 12x's equals 6 now.
And then just subtract 12.
Subtract 12. Is everyone with us on this? David's telling us, but stop me if you need to. So we've got 6 minus 12x.
Wait, can you stop?
Yeah.
Well, don't forget writing it and following it on what I'm doing and having a question are two different things. I'd like you to follow on step by step. We can always go back and write it afterwards. Do you have any questions on what we've done at that stage? No? All good. What would be the next step then?
Divide it by 3.
Yeah, because we want 1y, so we would divide that by 3, we'd divide that by 3. So we get 1y. What's this side if we divide by 3?
2 minus 4x.
2 minus 4x. So that wasn't too bad. So we've now got two equations in gradient intercept form. This one, are you happy it's in gradient intercept form?
Yeah.
What is m on this one?
2.
What?
Oh, no.
Yeah.
It is 4.
It's not 2 and it's not 4.
It's negative.
It's negative 4. Good.
Oh, yeah.
Because the gradient is the sign and the number before the x. The gradient of this one is 6.
I thought you were just talking about the intercept.
Why would I say m for the intercept?
I don't know. I was listening.
Okay, so gradient 6, intercept positive 7, gradient negative 4, intercept positive 2. Now, this is where I would maybe do this in my head, or I would do a little sketch roughly, just thinking, right, what are they roughly going to look like? Well, this one is going to start at 7 and go up quite steeply.
Yeah.
And this one is going to start at 2 and go down. Okay? And the reason why I've done that is like, now I know how to draw it accurately, right? So I'm looking for an intersection roughly in this part. That's why I did that. So I could do that in my head, or I could do a little rough sketch, and that guides the rest of it. Yes, Dave?
The x is negative 0.5 and the y is 4.
Have you drawn it, all of it? Well, we've got answers from previously. I want to be able to do this by graphing. So are you okay with graphing those now? Do I need to do it, or? Okay, well, you go for it then. Oh, I need to move that. So for me, because it's halfway through, I'm going to assume it's a half. It's kind of 3 down, like 4 is definitely halfway. So it makes perfect sense. But in this one, because my graph paper isn't particularly accurate because it's only the bigger squares, my check would be all important. So I would be going, right, is 4 equal to 6 times negative 0.5 plus 7? That's the question. Is that true? So I've got 6 times negative a half is negative 3. Negative 3 plus 7 is indeed 4. All right. And then the other check would be with the other one. So 4 should equal 2 minus 4 times negative 0.5. Okay.
Yeah.
So that's 4. Does it equal 2 minus, well, 4 times negative 0.5 is negative 2. So 4 equals 2 plus 2, which is 4. Again, I'm happy for both of those. All right. So my solution at 4 and negative 0.5 is the correct one. Okay. This is an important skill. So what we did to graph this one, we did convert to y equals mx plus c, which is absolutely fine. I don't mind you doing that. But I do want to go through the fact that it is possible to do this using another method that we've got to graph it using the other form, all right, which sometimes is a bit easier. And it is a skill you need, especially when we move on to the algebraic way. So I'm going to do only one step of the change, and I'm going to do 3y plus 12x equals 6. And the reason why I want to go through, can we graph that, is because this fundamental understanding of what this equation is all about is very important. And if you don't understand how to do graph using this, you probably don't understand what we mean by a function and its coordinates and things. So when we graph it, what are we trying to do? So we need to find x and y values that go together, yeah? That abide by the rule of this function. Is everyone paying attention to this?
Yeah.
Because if you're still focused on the previous one and trying to draw it, you're not paying attention to this. All right? So we are just trying to figure out a whole load of x's and y's, not a solution at the moment, just for this, what values of x and y go together. All right? How many do I need to draw the line? Just two, right? It's a straight line. I just need two pairs. What are the coordinates that go together, okay, that enable me to draw that line? So is there another way that we've got to do that?
Create 2 sets of coordinates.
All right, so how do I do that? No? We have gone through this a couple of times. Well, what we do is we pick a value to chuck into X and we work out what the Y needs to be. What values have we done in the past? 0. We found the axis intercepts, right? So we could just do this. What if X was 0? Well, 3Ys would equal 6. Therefore, Y would equal 2. What if Y equaled 0? Thank you. X would equal, well, it would end up being 12x equals 6, which means x equals 0.5. Okay, 6 divided by 12. All right, so now I've got 2 sets of coordinates, haven't I? All right, so let me hide that. So I can now replace my question marks, all right? So I know that when x is 0, y has to be 2, and when x is 0.5, y has to be 0. So I've got 0, 2, and 0.5, 0. How can I then use that to graph?
You just draw those 2
Just
points.
draw those 2 points, yeah. So I would be having a set of axes. I've already done my rough sketch, so I kind of roughly know where they're going to be. But I now know, for instance, that I'm going to have a 0.5. So I might choose, instead of 1 square, I'm going to go for 2 squares is 1, right? 1, 2, 3. So where would, so 1, 2, 3, where would 0, 2 go?
2.
So 0, 2. Where would 0.50 go?
Between 1 and 0.
Down there. So my line would end up going through those 2 points like that. All right. So it's a different way of graphing it. Now, like I said, look, that line is the same as that line. We ended up with the same thing, right?
Yeah.
So it doesn't matter, but I just wanted to go through the fact that you don't have to convert to gradient intercept form. Okay, now it is 5 to 10, so you've got 10 minutes. If you need to do the notes, fine. If you want to move on, basically you're going back to this graphing question that we did before. You've done them all using Desmos. I would like you now to do a couple, but graphing them by hand and confirm your results. Now, it would make sense to do one like B that's nice and simple with already mx plus c, but challenge yourself with something like F or G where they're a bit harder and you might need to rearrange first. Okay, so if you know, oh, gradient intercept, easy, I know what that's doing. Just move straight onto the harder ones. If you need a bit of practice, now I'm going to have to take this off the screen for those that need to write any notes. So you'll need books.